Good afternoon, morning, whatever time you're watching this. As I promised, I was going to make a video where I went over every problem on the Unit 7 study guide. Of course, the test will be on Friday. If you watch this, if you don't watch this, I said it was completely up to you. I wanted to do a quick recording. That way you could pause it. You could rewind it if you're watching it on your own. That way I wouldn't have to do this during every class. Class time will be specifically to answer the questions that you have. So I'm going to get right to it, and hopefully this won't even take me very long. As you can see on 1 through 9, there are two things that they want you to accomplish. One, determine whether it's exponential growth, or exponential decay. And then as you see there, it also says to determine the horizontal asymptote, which we'll talk about in just a minute. First, let's just knock out one thing at a time. So first, growth or decay. Remember, we talked about the focus being this. We want to look and find the exponent, sorry about that, and then immediately before that is the base of that exponent. So with every one of these, to determine growth or decay, we find the exponent and we immediately find the base of that exponent. We find the exponent and the base of that exponent. So I'm just going to do that all real quickly, and then we're going to go back and just talk about what it is. So the exponent and its base is my focus for determining whether it's exponential growth or exponential decay. So growth. Growth is when that base of your exponent is greater than 1. Decay is when the base of your exponent is less than 1. So I can quickly go through these and I can say, all right, number 1, what's the base? 2/3. That's definitely less than 1. That's decay. Number 2, the base is 1.5. Well, 1.5 is greater than 1. That's growth. Number 3, the base is 3. Growth. Number 4, the base is 1/2. That's definitely less than 1. Decay. Number 5, the base is 0.8. Definitely less than 1. Decay. Number 6, the base is 10/3. Yeah, I know it's a fraction, but 10/3 is definitely greater than 1, so definitely growth. Number 7, the base is 4. Definitely greater than 1, growth. Number 8, definitely greater than 1. It's 7/2, growth. And number 9, the base is 1/5. Definitely less than 1, so decay. All right, so we got all those knocked out. Really simple concept. And again, there's 9 examples because you're going to have, different ways that these exponential equations are going to look. So here's kind of a good grouping of the different ways you might see them. Now, the next thing is the horizontal asymptote. The horizontal asymptote, again, if you try to picture a x and y axis, a horizontal asymptote, we said for an exponential function, is a horizontal line that your graph can't cross. We said that if there's no transformations, the horizontal asymptote is right here on the x-axis, which is the equation y equals 0. But what did we say in class would cause that to actually change? We said it would be vertical shift. Whether it shifts up or whether it shifts down, that's what's going to cause it. So vertical shift happens on the outside. So therefore, our focus is the values that are being added or subtracted on the outside, meaning not up in the exponent spot, but on the outside. See, here's up in the exponent spot. Outside would be down in here. So if you notice, there's nothing being added or subtracted to this problem. So therefore, in this one, our asymptote would not change. It would be y equals 0. But number 2, you notice that there is a change on the outside, that plus 2. So that tells you that your asymptote is shifting up 2. So your new asymptote will be at y equals 2. So look at all these. This one is on the outside at -1. This one's on the outside, -5. There's nothing on the outside here being added or subtracted. Here, +3 is on the outside. Here, nothing. Here, -7. And here, +6 on the outside. So real quickly, if I understand that, I know that my asymptote on number 3 goes down 1, so y equals -1. My asymptote on 4 goes down 5, so y equals -5. My asymptote on 5 will not change, so it'll stay y equals 0. Number 6, it goes up 3 to y equals 3. Number 7, it goes up 6 to y equals 6. Number 8, it goes down 7 to y equals -7. And then number 9, the last one, no change. So it's y equals 0. So be prepared on the test to be able to look at the equation and determine, without graphing it, of course you could graph it, but you should be able to determine without graphing whether it's showing exponential growth or decay and where the horizontal asymptote goes to. All right? So pretty easy problems. Let's keep on moving. The next grouping, you're rewriting either exponents as logarithms or logarithms as exponents. So really, really simple. There's just a couple things that I want you to remember. Remember, if it's a base other than 10 or other than e, we're going to use log. So for example, number 10, my base is clearly 8. So the base of my exponent 8 becomes the base of my log. Log base 8. And then, and I'm not going to do this every time, we're going to do the loop. Log base 8 of what? 64. Equals what? 2. See, we just complete that loop. And every one of these you do the same way. So, without doing that every time, number 11, the base of my exponent is 2. That becomes the base of my log, log base 2, of 32 equals x minus 4. And we don't have to solve these. It just wants me to write them in logarithmic form. Now, number 12 is a little different. See, it has a base of 10. The only way that's different is when I write log, without putting a base, it's understood to be base 10. So I don't have to put the 10 there. Now, if you did, it's not like it's going to be wrong. It's just no reason to. So it's just log, and then you do the loop of 54 equals 2x. Now, very similar to that, here you have a base of e. Well, we said when we have a natural base, we're going to use natural log because it has an understood base of e. So kind of like that last problem, I don't need to put the e there. So it's natural log of x minus 2 equals 6. Now, make sure you understand, I put this parenthesis here because when I take the natural log of e, base e, of the other side, I have to tell my paper and whoever's looking at it that the entire thing x minus 2 is my argument. That way it doesn't think it's just natural log of x and then it's subtracting 2, shifting down. We put the whole thing in parentheses. All right, let's keep on going. Here we have another base 10, so I'm just going to do log of 30 equals x plus 1. Now it's switched back. We've got a base of 5, so log base 5, and then we do the loop of 25 equals 2. Number 16, it's base e, so I'm going to use natural log understood base e of 7 equals x. And then lastly, another e, so natural log of 6 equals x minus 2. So whether you're going from logarithmic to exponential, or as we're about to do exponential to logarithmic, there's multiple ways you might see these things. Be prepared for any of these on the test. Now let's go the opposite direction. If we go to our or keep that same thing in mind, we're now rewriting logarithms as exponents. So it's the reverse mindset. The base of my log now, in this case, for example, you've got base 3. The base of my log becomes the base of my exponent. And then like we just said, you still do the loop. 3 to what power? The fourth power. Equals what? 81. See, you're just completing the loop. Again, it's the same even with logarithms to exponents. So here we go, number 19. The base of my log, x, becomes the base of my exponent. And then we do the loop. Raised to the 1/2 equals 7. Now don't forget, when you see a problem like number 20, there's no base written here. Why? Well, it's common log. It's understood to be base 10 to the second power equals 100. Same with the next problem. There's no base written there. Well, it's natural log. It's understood to be base e to the 38th power equals x. Okay, same with number 22. Understood base e to the x plus 1 power equals 2. Number 23, it's common log. No base drawn there, so we know it's 10 to the 5th power equals x. Number 24 has a base there, so it's 4 to the 3rd power equals x plus 1. And last one is another natural log, so it's understood base e to the x power equals 5. Again, pretty simple stuff. I hope that you guys recall this. I don't foresee you having any trouble with these kind of problems on the test. Now, here we're going to go to our calculator and we're going to type these in. So I'm going to leave and just go over here to my calculator, and I'm going to type all these in with you. Okay, don't forget, log base 9 of 81, we're going to go alpha window number 5. We're going to plug in our base 9 of 81 equals 2. And that's all you have to do when it says evaluate each logarithm. Number 27, alpha window number 5, base 7 of 95. And I would round to about right here, 2 decimals, so that's 2.34. Number 28, it's just log of 63. So I'm just going to push this button now and then do 63. So I get 1 point. It looks like this 9 right here is going to round that up to a 10, which rounds that up to an 8. So it's just going to be 1.8. Again, not going to get too worked up on the test Friday, as long as you're really close in your rounding. The next one is just ln, so go push this button, of 42 equals, and that looks like that 7 is going to round that up to a 4, so I'm going to write 3.74. Let's keep on going. We got another one where we go alpha window number 5, base 81, whoops, I didn't mean to do that, 81 of 3, and that gives me 0.25. You could write 0.25, or you could put 1/4 if you wanted to change it to a fraction. The next one is just log, so I'm going to push this button of 109 equals, that's 2.04, because this 7 right here rounds that up to a 4. And then we've got just an ln again of 92, and that's 4.52. And then lastly, we've got another log base 2. So alpha window number 5, log base 2 of 78, and that's approximately 6.29. Okay, so let me go back to my paper, and we'll go back and forth a little bit whenever calculators are needed. But there you have all those values that all you had to do was use your calculator to solve. Should be pretty simple. Let's keep on moving. So here it's asking us to solve logarithmic equations. So remember, there were two ways to solve logarithmic equations. One, if it's log equals log, you drop off the logs. Or if it's log equals a number, we said to rewrite it as an exponent. So that's what we're going to apply here. Rewrite as exponent. So if you look at this problem right here, it's definitely log equals log. So I'm going to drop off these logs. Now when I do, that's going to leave me with y plus 5 squared equals 4. And we haven't seen a problem like this in a minute or two, but it's real simple. Remember how we get rid of this? We want to get y alone. Remember how we get rid of that square? We take the square root. And when we take the square root, it allows those to cancel, and y plus 5 drops down on the left side. Do you remember the rule when we took the square root of both sides? You had to add plus or minus to both answers, or to that right side, and the square root of 4 became a 2. To solve this thing, I'm going to subtract 5, so y will equal negative 5 plus or minus 2. So really, here's my two possibilities, my two answers. What's negative 5 plus 2? See, I do negative 5 plus 2. Well, that's negative 3. And we also do negative 5 minus 2, which is negative 7. So we had two of those answers, and I think if you plugged them back in, negative 3 plus 5 is 2, 2 squared is 4, negative 7 plus 5 is negative 2, squared is positive 4, so it would both be log of 4 on both sides, so they would definitely be equivalent. Now look at 35. See, 35 does not have log on both sides. It just has it on the one side. So we've got here log equals a number. So we're going to rewrite it as an exponent. So the base of my log, 2, becomes the base of my exponent. And then just like we were setting those up earlier, we're going to do the loop. 2 to the 7th power equals 9m plus 2. So go to your calculator, and 2 raised to the 7th power is 128. So 128 equals 9m plus 2. Now solving from here, you're going to subtract, let me go back, sorry. You're going to subtract 2, so that's 126 equals 9m. And then you're going to divide by 9, and m equals 14. Okay? So real simple, okay? Whether it's log equals log or log equals a number, we can do it. Look at number 36. Definitely see a log on both sides. We're going to knock them out. And this problem is very similar because you're going to have one that looks like this on the test. You're left with p minus 2 squared on the left side equals 9. Once again, how do I get rid of that square? I take the square root of both sides. We have to add plus or minus to my answer. And the square root of 9 is 3. So last we're going to add 2. So p equals 2 plus or minus 3. So here are my two possible solutions. 2 plus 3 is 5. And 2 minus 3 is negative 1. So positive 5 and negative 1. Okay, and the last one. Now, you don't see log on both sides, right? So we are going to rewrite as an exponent. However, here's my logarithmic expression right there. It's a natural log, but still, there's something on that left side that has to be moved first. And that is, we got to divide both sides by 5. Now, when we do that, then sure enough, I'll be left, these cancel, I'll be left with ln of 2a minus 1. And on the right side, 15 divided by 5 will equal 3. So we are going to now rewrite this as an exponent. Now don't forget, when there's nothing here and it's natural log, ln, that's understood to be an e. So I'm going to write e to the third power equals 2a minus 1. So let's go write e to the third power in our calculator. Remember, there's a couple places to find it, and I won't tell you this on the test. You can either do second divided by, or you can do second ln. And we're going to raise it to the third power. So e to the third is 20.09. Let me write that. 20.09 equals 2a minus 1. Let me go back to my paper, because y'all can do the rest from here pretty easily, I think. You're going to add 1, so that's 21.09 equals 2a. And then you're going to divide by 2, so if you do this in your calculator, it would round to about 10.55. So log equals a log, or log equals a number. I expect that you can do this. Now moving on. Exponential, we've got two options as well. You can either, if the bases are the same, you can drop off the bases, or if you can't, you're going to rewrite it as a logarithm. So very similar. Now, right off the bat, we were kind of given a tricky problem, because if you look at 38, here's my exponent. That tells me it's an exponential equation. And right there, that 3, that's the base. We can't solve this until that is alone. So what do I need to move first? Definitely the 11. So 2 times that 3 to the 4y will equal 72. Now, once again, I am not ready to get this or to solve this until I got this alone. So I divide by 2. So 3 to the 4y equals 36. Now we've isolated it. So hopefully you now remember that to solve this thing, we're going to rewrite it as a logarithm. And the base of my exponent, 3, becomes the base of my log. And then we do the loop. Log base 3 of 36 equals 4y. So let's go to our calculator. Alpha, window, number 5, log base 3 of 36 is approximately 3.26. So 3.26 equals 4y. So now all you got to do is divide 3.26 by 4. And if you type that in, and I don't need to go back and type it because all y'all know how to do that, you divide by 4, you get 0.82. So there it is, solving an exponential equation. Now 39 is pretty easy, because if you look at your exponent and its base, it's already isolated. The only trick to this problem is its base e. So I'm going to use a natural logarithm. Why? Because it's understood base e. So I'm going to do natural log and then the loop of 65 equals a plus 1. So I'm going to go to my calculator and I'm going to use the ln button of 65, and I'm going to get 4.17. So 4.17 equals a plus 1. So all I got to do last is subtract that 1. So a equals 3.17. Pretty simple stuff. I think you guys all will agree. Number 40. Again, it's exponential, we know, because there's a variable up there in the exponent spot. And then here's its base. It's already isolated. So I'm going to go ahead and rewrite this as a logarithm. So I do the log base 8 and then the loop of 48 equals n minus 5. So if I go type in alpha window number 5 log base 8 of 48, I get 1.86 equals n minus 5. So pretty easily we're going to add 5 here, and the answer is 6.86. All right, moving along. This one's a little tricky. It's got a lot of stuff going on. here we've got the exponent and its base. So we need to move all this other stuff away from it. So I'm going to add 7 first. So negative 34 plus 37, we'll come back to that in a second. Let's write all this stuff up here. Negative 34 plus 7 is negative 27. Look, I'm still trying to get this exponent and its base alone. So how do I move that negative 3 that is multiplying by it? I divide. So when I divide, negative 27 divided by negative 3, I get a positive 9. So here's my exponential equation. It's a base e. So when I rewrite this as a logarithm, I use ln, understood base e, of 9 equals 2m minus 5. So let's go type in ln of 9. I get 2.2 equals 2m minus 5. All right, let's go back to our paper. So we're going to add 5. That's 7.2 equals 2m. And then I'm going to divide by 2, so m equals 3.6. All right, so solving exponential equations. Hopefully you guys understand and you'll do well on this on Friday. All right, so here's all your formulas that you're going to have given to you on the test. So we're going to move through here and try to figure out, 1, what formula to use, and then 2, we'll answer all the questions that these questions ask. So 42. Sophie's collection of dolls from the 19th century currently values at $77,000. The value increases by 11.7% annually. Write a function to represent the value of the doll collection after T years. So the first thing we want to do is just write an equation. So first of all, out of all these equations, which one is just increases by 11.7% annually? See, it doesn't say compounded. So that gets rid of these two right here. It never says anything about doubling or tripling, so those are gone. And which one of those left represents increasing? Well, it's definitely this one. So we're using appreciation, okay? We're using appreciation. So I'm using the equation A equals P times 1 plus R to the T power. Let's fill in all these and write the equation. 1, we don't know what A equals, but we do know that our principal amount is $77,000. Times 1 plus our rate is 11.7%. Remember, we're moving that decimal 2 to the left, so that's 0.117, and then that's raised to the T power. So if I were to write this formula completely simplified, now you can leave it like this, but if I wrote this completely simplified, if I were taking a test that were multiple choice, it would have added that and made it 1.117. That technically is the simplified version of that equation. Now, the last part of this, it asks 2 questions, is to find the value of the collection in 2025. Now, some people looked at the question like, what, do I go from the 19th century? Well, I don't know what year to go in the 19th century. No, it says it currently values at $77,000. Well, guys, what's the current year? It's currently 2023. So if I want to figure out what it will be worth in 2025, what do I plug in for T? Well, obviously I plug in 2. So go to your calculator and type in 77000 times 1.117 raised to the second power. Okay? So let me clear this so we can. So I'm going to type in 77000 open parenthesis 1.117 raised to the 2 years. So it's going to gain some pretty good momentum at 11.7%. So after that short amount of time, it's going to be valued at $96,072.05. And there it is. Okay, let's go back to our paper. That answers both of those questions, so we can move along. 43. A baseball card that was valued at $200 in 1980 has increased by 7%. Write a function to model this situation, and then find the value of the card in 2022. All right, so look at all the things. One, they want us to write the equation. So it was $200 increased by 7% each year. Well, guys, once again, this is appreciation. So A equals P, 200, times 1 plus the rate, 7%. Look, if 7%, if the decimal is understood to be there, I move it 1, 2 to the left. So that's going to be 0.07. 0.07, and that's raised to the t power. So again, if I like to simplify these equations, so it would be A equals 200 times 1.07 raised to the t. That would be writing the function to model this situation. Now, what about finding the value in 2022? Well, 2022, it's a little different than the last question because they told me that it was $200 back in 1980. So what is 2022 minus 1980? Well, that's 42 years. So when I try to find the value now, I'm going to use my equation, 200 times 1.07, but I'm going to raise that to the 42nd power. So 200 times 1.07 raised to the 42nd power. So that's going to equal $3,428.85. Okay, let's move on down. Let me put that back up in case you didn't write it down. Let's move down to number 44. I'll leave that up for a second while you still write. Miles invested $2,400 into a retirement account that earns 1.8% compounded monthly. Write a function to model this situation, and then find the balance after 25 years. So it wants me to do both. It wants me to write the equation and find the value after 25 years. So first, what formula? Well, that definitely said compounded monthly. This is compound interest, which is P times 1 plus R over N raised to the NT power. So here we go. A equals P, 2,400 times 1 plus, my R is 1.8%. That's 0.018. Please don't forget to move your decimal 2 to the left. Now here's the part, of course, that you have to think a little bit about. It's N, and that represents the number of times it's compounded every year. Well, they use the word monthly. We said that monthly was 12. So I'm putting 12 in both of those locations. Now, let me go simplify. I'm going to leave 2,400 alone. I'm going to leave the 12t obviously alone, but I want to go type this into my calculator. 1 plus alpha y equals, number 1, 0.018 over 12. And that broke down to 1.0015. So hopefully you got that too. There's my equation to model this situation. Now, how do we find out what it is after 25 years? We take 2,400 times 1.0015, and we raise that to the 12 times 24/5 power. So I'm going to go in here, and I'm going to type in 2400 times 1.0015, and that's raised to the 12 times 25 power. And I get $3,762.68. All right, go back, put that back up for a couple minutes. Well, not a couple minutes, but long enough for you to see that you wrote it all down correctly. And then we'll move along to the back side, last side. All right, here we go. I forgot. You could pause it if you wanted to, or rewind it if you need. Number 45. Sarah invested $4,000 into an account that earns 3.5% compounded quarterly. How much will be in the account after 15 years? Does this one ask me to write a function to model it? No, I just need to solve it. So first I need to know, this said compounded quarterly, so just like the last problem, we're using compound interest. So here we go. A equals P, that's 4,000, times 1 plus R. That's 3.5%, or 0.035 over N. Well, guys, what is N? What does quarterly mean? It means that you're compounding it 4 times a year. And that's raised to the 4 times 15 power. See, I didn't have to write the equation, so I'm just going to plug all this stuff directly into my calculator, into the formula. So here we go. Let me clear all this out. I got 4,000, open parenthesis, 1 plus alpha y equals, number 1, I had 0.035, 0.035 over 4, and then all of that was raised to the 4 times 15 power. So when I calculate that, or actually when the calculator calculates it for me, I got $6,746.41. So there you have it. You didn't have to write the equation, you just had to solve it. So I just plugged everything directly into the equation, directly into my calculator. Okay, number 46. Number 46, a culture contains 600 bacteria. The number of bacteria doubles each day. How many bacteria will be in there after 8 days? So once again, it's not asking me to write the equation, it's just asking me to solve. So the formula for this clearly is the double formula. It started with 600, it's doubling, and they want to know how much is it after 8 days. So real simple, 600 times 2 to the 8th power. So after 8 days, we're expecting there to be 153,600 bacteria cultures. Or bacteria, sorry. Okay, so let me go back. That's what you should have, 153,600. All right, let's keep on moving. I'll leave that there in case you didn't quite get it done. This question says, each day, Jeremy deposits 3 times as much money as he did the day before. His initial deposit was $2. Write an equation to model this daily deposit, y on day x. So instead of a, I'm using y equals. Now what formula is this? Well, it says he's depositing 3 times as much every day. So this is the tripling formula. So that's simply P, 2, the initial amount, times 3, raised to the t power. And they wanted me to use day x. So it's y equals 2 times 3 to the x. Now, if you look back at the problem, you notice it never asked me to find out how much there is on a certain day. They just wanted the equation. There it is. Number 48. I'll leave that up. 48. You invest $150 into an account with 2.5% compounded continuously. How much money will you have after 10 years? So once again, this is not saying, hey, write the equation. It's just saying solve it. Now, what formula do I use? Compounded continuously. That is the A equals P E to the RT. So what is P? What's my principal amount? 150. E is my mathematical constant. You'll find it in your calculator. I'll show you in a second. We've already looked at it. Raised to the R, that's 2.5%, which is 0.025 times 10. That's the number of years. So I'm going to go plug this in. So I'm going to type in 150 second ln. So that's 150 times e raised to the 0.025 times 10 power. So we can expect there to be $192.60. So let me go back. Here it is. All right, last one. You invest $1,000 into an account with 3.5, so 1,000 into 3.4, I'm sorry, and once again, compounded continuously. How much will you have after 8 years? So almost identical to the previous problem. We're going to do A equals P, that's 1,000, times E raised to the RT power. Well, R is 0.034 times T, which is 8. So let's go type that in. 1,000 times E, second, ln, or second divided by, we're going to put 0.034, that's our R, times our T value, or 8. So after 8 years, we expect $1,312.59. So go back, show you that, and as you can see, that's the last problem on the review. So that should get you guys prepped for your test. All right, so again, watch this, study, be prepared, and I think if you do, you're going to do just fine on your test on Friday. All right, I'm going to upload this. Hope you have a good day.